So here's a demonstration of the Shimatsu GC. When you walk up to the instrument, first you have to log into the computer. There's no special login. You can log in as yourself. It takes you to the same desktop. And then there's a power switch on the front of the instrument that needs to go on. And there's two tanks that need to be opened. This one with the red handle is the hydrogen tank for the flame. So at the top of the tank, you just open it all the way counterclockwise, and make sure that that this valve, which lets the hydrogen go to the GC, is also all the way open counterclockwise. This one is the helium, which is the carrier gas. Same thing, just open completely counterclockwise, and now we've got hydrogen and helium. All right, then on the software, there's an icon on the desktop that says Lab Solutions that you can double click on. And this little blue square up here that has all the letters and numbers, that's the only GC that's connected. So we double click on that one. And then it beeps when it's connected to the instruments. So now in the simplest experiment, we should start by just going to Acquisition and clicking on Single Run, and then clicking OK. And we need to do this even before we're ready to run an experiment, because this and all these other windows are going to pop up, but we can just OK out of all of them. And this is going to prepare the instrument to do a run. So now on the instrument, it's got to come up to temperature, and the detectors have to light. And to see if it's doing this, we can do two things. We can go to Monitor and Temperature, and then it shows you the actual temperature and the setting, and we have to wait for these temperatures to match the setting. The exception to that is this SPL2, which is the second column, which is not installed. That one's okay if it's not moving. But the others should come up to the setting where they're matched. And the other thing we can monitor is the flow. And same thing here. We're waiting for these blinking numbers to match the settings. So once the temperatures match, it's going to be maybe a minute on this one, the column, to come up with temperature. And once the flows match and everybody stops blinking, then you might hear a couple little pops, and that's the detector lighting. So we're still waiting for a green light up here, a couple green lights for temperature and flow. But if you don't hear those pops for the detector lighting, then you're not ready to run an experiment yet. So, all right. So now we got green lights on temperature and flow. Even though these didn't quite get up to 400, they stopped blinking, and we got green lights, so we're all right. So now, in order to do an injection, you're going to have a sample. A common experiment is this ethanol in wine experiment. So we've got some ethanol here, but it could be any sample. It's got to be something that's somewhat volatile, right? GC is for detecting things that are volatile compounds, so it's not a great choice for everything, but certainly ethanol is pretty volatile. So we're going to take a syringe, a GC syringe, and you know it's GC because if you look at the, I don't know if you can see that, but if you look at the tip of these things, the GC syringes are tapered, they're sharp, so that they can punch through a septum. And we're going to draw up some sample, and we only want to inject 1 microliter, right, which is just the 1 microliter mark on the sample, so just the very tip of it. And when we inject, we're going to go into the injector that has the injector 1 sticker next to it, It's the one that's closest to the front. And this is kind of a pain because you have to get the needle in just the right place. So we're going to punch it through, and if we feel some resistance, we're going to stop. And we may have to do this a couple times, but ultimately you should be able to get the syringe all the way down, push the plunger, and pull it straight out. And then we're going to click Start on software. It's going to give us some things that we can click OK on a couple times, a septum counter warning and something else. And then we should see our baseline start to scroll along the bottom of this chromatogram. Now, this thing does not auto scale, so if we have very small peaks, we might not see them. We can come over here to the magnifying glass and click plus, and it'll zoom in. Or if the peaks go off the top of the plot, we can click minus, and we can zoom out. But alcohol, ethanol in particular, should give us a peak within a couple minutes. So we're just looking at this baseline right here and hoping that we get a peak as the ethanol makes it through the column and comes out to the detector. And of course the things that have higher boiling points are going to take longer to come out, and the lower boiling point things will come out sooner. All right, so this peak has gone off the top. Right, it started to go up and it went way off and we can't see the top of it, so I can come over here to my magnifying glass and click down a couple times, and it'll scale down and put the peak on the graph. And since we only injected one thing, right, we injected pure ethanol, we know that this is the only compound in there, and this peak's come back down to baseline. So if we know we're done, we're ready to stop the run, and we can get an area for this peak that indicates how much ethanol is in there. So to stop it, back to acquisition and stop, and it asks if we're sure, we can say yes. And this will stop the data acquisition. And then usually what we want to do is get peak areas for the compounds that came out. So in order to do that, we have to go to the data and browse line 1, which is the first option under data. And this takes us actually to a different application where we've got the peak in a different scale. And then down here it gives us areas for the peaks. So this is a little tricky because it tends to integrate even really very small things. So if you look down here, it says that there's 12 peaks in this chromatogram, and if you look at the chromatogram, it looks like there's probably only one peak, which is the big one that we're interested in. So there's two things you can do. I mean, one is you can look at this the area column, and you can see that one of the peaks has just a much bigger area than all the others. So that's the one, that corresponds to our big peak in the chromatogram. The other thing you can do is look at the time when the peak comes out. So this peak comes out between 1.5 and 1.75. So if we look in the chromatogram, or in this table under retention time, again, this biggest peak comes out at the retention time that's between 1.5 and 1.75. So we can guess that this peak right here, number 11, is the ethanol peak. We can read the area out of the area column, and then if we wanted to do another run, now we can X out of this post-run analysis after we've got areas. That takes us back to the application that runs the instrument. We can go back to acquisition, back to single run, okay, and this takes us back to the start menu. So now we could do another injection of our second sample, and when we click start, it'll erase the old chromatogram and give us a new one. And here we go with our baseline for our second sample. All right, so that's basically how you use the GC. When you're done with it, when you're done with all your analyses, you can X out of all the software, which takes you back to the desktop. You need to turn off the power switch on the front of the instruments, and this is very important. This is the hydrogen tank that we want to make sure is closed after we're done using the GC, right? And the way we're going to close it is just on the top of the tank. Just turn this completely clockwise so we don't have hydrogen leaking into the lab, right? It doesn't really matter. You can leave that open as long as the tank is closed. This one is the helium, right? Less of a concern than the hydrogen, but still probably a good idea to turn the top of the tank completely clockwise to turn it off, and then you're done.